In this video, we are going to review some of the 5th grade math curriculum, and my dog Jack here is going to help us along. Folks, you see a list of some of the topics I'd like to cover. It looks daunting, but we're going to take them one at a time. We're going to go nice and slow, and I encourage you as we move through the video to try the problems on your own first, and then proceed to replay the video, and you can see how I proceed to solve them. So first we're going to talk about things like factors and prime numbers. Then we're going to move to decimals, talk about how to multiply decimals. Then we're going to move through exponents rather quickly, and then spend a lot of time on fractions. I'm going to do this video in multiple parts. Again, this video series is designed to help you. You can pause anytime, you can come back. You don't have to watch the entire video series all at once. That's the nice thing about video. Okay, so as promised, one of the topics we're going to talk about is factors. Okay, what is a factor? Factors are two numbers that are multiplied. So whenever you have 2 times 3 equals 6, or 1 times 6 equals 6, these numbers here, all of these, are considered factors of 6. The reason is they are involved in the multiplication process to create the number 6. The way I think about it is factories create things. So factors create a given number, and they have to be whole numbers. You'll never see something like this, that 2 1/8 is a factor of such and such. You won't see that. You only see whole numbers. Okay, so let's talk about factors in more detail. Suppose you were asked in class to provide the factors of the number 8. Okay, what I like to do with my students is go ahead and put that number in question in a box. And then what we want to do over here is come up with all the numbers that can be multiplied together to result in the number 8. It's always best to start with 1, because 1 times the number itself are always factors of a given number that's in the box. So we start with 1, then we move to 2, and we ask ourselves, is there anything that we could multiply by 2 to give us 8? And the answer is yes, we can multiply it by 4. Okay, so let's go ahead and do this. Okay, so right away we already have 4 factors of 8. So far, let's write them over here. We have 1, we have 2, we have 4, and we have 8. Okay, so let's keep going. Is there anything that we can multiply 3 by to give us 8? The answer is no. So 3 is not going to be a factor. Let's move to 4. Is there anything we can multiply 4 by to give us 8? Well, yes, you can multiply 4 by 2. So once we reach one of the factors, and we're going backwards here, we could stop. Okay, so we could stop at this level right there. There is nothing else that is going to give us 8. 5 times something, no. 6 times something, no. 7 times something, no. 8 times something? Well, yeah, 1, but we already have that. And the protocol is not to repeat the factors. So once you have 2 times 4 here and you list 2 and 4 as a factor, there's no need to repeat it with the 4 times 2 and or the 8 times 1. So that's it. Those are the factors. It's typical that we place them in ascending order, which means from smallest to largest. Okay. Okay, let's move on. Suppose our teacher asks us, what are the factors of 5? What numbers, when you multiply them, will result in 5? Again, folks, we always start with the number 1. 1 times itself, okay, 1 times the number in the box are always going to be factors. Can we use 2 to multiply something to give us 5? No. How about 3 times something? No. 4? No. 5 times 1. We are in repeat mode. So now that means we're done. We're done up here. Turns out the only factors of 5 are 1 and itself. That makes 5 a special type of number, a prime number. Prime numbers are when the only 2 factors are 1 and itself. Let's keep going. Let's identify the factors of 10. We put 10 in the box. Remember, factors, like a factory, create a number. 1 times 10. 1 in itself are always factors. We have 2 times 5. 3 times something? No. 4 times something? No. 5 times 2, we're in repeat mode. We stop right here. Here are our factors. Now, ladies and gentlemen, because there are more factors than 1 in itself, this is called a composite number. Okay, let's do one more. How about the factors of 20? We have 1 times 20. We have 2 times 10. 3 times anything? No. 4 times 5? Yes. 5 times 4, we're in repeat mode. We stop here. Here are the factors. 1, 2, 4, 5, 10, and 20. Okay. Folks, I'd like you to try these on your own. Pause the video. Take your time. These are hard. They're large. Provide me with the factors here. Okay, I assume that you paused the video. Here are the factors of 24. We have 1 times 24. We're going to have 2 times 12. We're going to have 3 times 8. We're going to have 4 times 6. And that's going to do it. Lots of factors. Let's now move to 48. We're going to have 1 times 48. We're going to have 2 times 24. We're going to have 3 times 16. We're going to have 4 times 12. I'm running out of room. And we're going to have 6 times 8. Tons of factors. 1 times 48. 2 times 24. 3 times 16. 4 times 12. 5 times nothing works. 6 times 8. 7 times nothing works. 8 times 6, we're in repeat mode, so we are done. Okay, folks, now we're going to talk about another topic called a multiple. Okay, and I think it's helpful to talk about multiples in the context of a factor. So let's put a number in the box. And let's put factors over here. The factors of 6 are going to be 1 times 6, 2 times 3, and that's it. Factors create a number. Now, multiples are when you take the number in the box and you get bigger. You get bigger. How do we do that? Well, we take 1 and multiply it by the number in the box. We take 2, we multiply by the number in the box. We take 3, we multiply it by the number in the box. Folks, these are multiples over here. They are bigger versions of the number in the box, or equal to. Okay, we always start off with the number of the box in the box, 1 times 6, and then we get bigger. Notice, each time we advance, we're advancing by the number that's in the box. So there's 2 ways to create multiples. We can either keep going with our multiplication, especially if we're adept at our multiplication tables, or we could quote-unquote count by 6. Namely, add 6 to the preceding number. So if we add 6 to 18, we're going to get 24. If we add 6 to 24, we get 30. We could add 6 to 30, that would give us 36. Or we can continue with this progression and now do 6 times 6, which we know to be 36. So to review, factors, like a factory which creates things, factors create the number in the box. Multiples make the number in the box bigger. 2 ways to get multiples. We start with 1 times the number in the box. We keep going, 2 times the number, 3 times the number, etc. Or we count by the number in the box, starting with the number itself. 6, 12, 18, 24, 30, 36. Let's do another one. What are the multiples of 10? Put 10 in the box. Start with the factors. The factors of 10 are 1 times 10, 2 times 5. These numbers create the number in the box. Multiples. We're going to get bigger. We're going to do 1 times 10, 2 times 10, 3 times 10. Folks, these are the multiples of 10. Now notice, unlike the factors where there's a finite number of them, meaning there's only 4 factors, with multiples, you could go on and on and on forever. There is no limit to the number of multiples. We could go 4 times 10. Okay. It's 40. 5 times 10. We can go all the way down to 70 times 10. Which is 700. This is still a multiple of 10, so there is no limit. Again, 2 ways to get a multiple. Start with 1 times the number in the box to get the multiple, and then go to 2 times 10, 3 times 10, or you can keep adding the number in the box as you go. We're adding 10. We're adding 10. We're adding 10. Or we're counting by 10. 10, 20, 30, 40. Making multiples. Making bigger numbers. Okay, let's put a number in the box. 8. Folks, I'd like you to pause the video and provide me with the factors and the multiples of 8. Okay, I assume you gave it a go. We're going to start with the multiples. 1 times 8, 2 times 4, and that's it. I'm sorry, I misspoke. We're going to start with the factors. I apologize. Factors, there's a limited number of them. Multiples, you can literally go on forever. Usually I ask my students to provide me with the first 5 multiples. So let's do that. 1 times 8 equals 8. 2 times 8 equals 16. 3 times 8 equals 24. 4 times 8 equals 32. 5 times 8 equals 40. You want to give me a few more, we're going to count by 8, 48, 56, and 64. Multiples get bigger. Factors are what you use to create the number in the box. Multiples make the number in the box bigger. Okay. Folks, on your own, I'd like you to try the factors and the multiples of 20. Okay, I assume you gave it a go. 1 times 20. 2 times 10. 4 times 5 are the factors. The multiples. We're going to get bigger, folks. 20. 40. 60. Now we're going to count by 20. 80. 100. 120. Each time we're adding the number in the box. Okay. One of the things you'll see in math is something called the greatest common factor. Okay, let me open this up again. Okay, here it is. Here's our list. Greatest common factor and the least common multiple. Let's talk about the greatest common factor first. Okay, let me write it here. It's often abbreviated as the GCF. Greatest common factor. Okay. What does the word common mean? It would help if I wrote the whole word out. What does this word common mean? Common means it's shared. Or like if someone says you have something in common with somebody, it means you both have this same characteristic. Let me give you an example. If we have John's favorite ice cream flavors are vanilla, chocolate, and strawberry. And we have Debbie's flavors are mint chip, her favorite flavors, mint chip, black cherry, and vanilla. Folks, do the two students have any favorite ice cream flavor in common? Yes, vanilla. Here it is. This is a common favorite flavor. Okay, so what we're going to do here when we talk about greatest common factor is we're going to give you two numbers. Okay, I'm going to give you two numbers, 6 and 8, for example. And we're going to look at the factors of each. Here they are. And then we're going to ask, do they have any common factors? Well, the answer is yes. 2 is a common factor. By the way, we all know that every number has a factor of 1, so we really don't mention that. It doesn't really help us. We're always talking about numbers bigger than 1. So do 6 and 8 have any common factors? Yeah, 2. Just like John and Debbie have the common flavor of vanilla, these are common factors. Now, if there's more than one common factor, here they want the greatest one. So let's say we have two numbers that share more than one factor, we would choose the highest one. And we'll see examples of that in a second. Okay. So whenever you see the word common involved, it means you're going to have two numbers. Okay, so here they are. Just like when we talked about common favorite flavors, we had to have two people. In order to use the word common, we have to have more than one of something. Same thing here. Common factors, or in this case, the greatest common factor, we need two numbers. Here they are. Folks, what are the factors of 6? 1 times 6, 2 times 3. What are the factors of 9? 1 times 9, 3 times 3. Do they have any common factors? They do. It turns out they only have one factor, therefore the greatest common factor is going to be 3. Let's do another example. What about 10 and 15? Factors of 10, 1 times 10, 2 times 5. Factors of 15, 1 times 15, 3 times 5. The one and only common factor is 5, therefore it is the greatest common factor. Okay, let's look at two more numbers. Let's look at 18 and 12. We have 1 times 18, 2 times 9, 3 times 6. For 12, we have 1 times 12, 2 times 6, 3 times 4. Any common factors? Yes. 2 is a common factor. 3 is a common factor. 6 is a common factor. Of all these common factors, which is the greatest common factor? The answer is 6. So that is the GCF. Folks, we're now going to move on to something. Let's go to our list, see if we have it. Least common multiple. See that word common? That means we're going to have to be comparing two numbers. So let's do that. Now, folks, we're going to be talking about multiples. Let's look at 4 compared to 5. With multiples, we get bigger. Here are the multiples of 4. Let's do the first few. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 equals 12. 4 times 4 equals 16. 5 times 4 equals 20. Let's stop there. Common multiples of 5. Multiples of 5. 1 times 5. 2 times 5. 3 times 5. Okay, now let's count by 5. 20, 25, etc. Do they have any common multiples? Let's see. They do. 20. So 20 is the smallest common multiple. Notice, we could have kept going. We could have done with, let's go to 4. We could have gone all the way up to 4 times 15 equals 60. Okay. We could have kept going. We would have gotten 4 times 15 equals 60. And with the number 5, we could have kept going. And we eventually would have gotten to 5 times 12 equals 60. So 60 and 60 are common multiples between these two numbers. But when we do these problems, your teacher is going to want the least common multiple. So once we get a common multiple, these problems are over. Let's do one more. What is the least common multiple, when you write it here, LCM of 10 and 9? Multiples get bigger. 1 times 10 is 10. 2 times 10 equals 20. Okay, let's count by tens now. So we have 20, 30, 40, 50, 60, 70, 80, 90, and 100. Multiples of 9. 1 times 9 equals 9. 2 times 9 equals 18. 3 times 9 equals 27. Let's count by nines now. Again, each time we're adding 9. 36, 45, 54, 63, 72, 81, 90, 99. Okay, we got a common multiple. The LCM, least common multiple between 10 and 9, is indeed 90. Okay, folks, we're going to do one more topic on this video, and then we're going to move on. Let's get our list out. Okay. See this here, prime factorization? We spoke briefly about prime numbers. We've spoken about factorization. Now we're going to put the two concepts together. Prime factorization. Let me write it down. Prime factorization. Okay. This is what this is about. When we do prime factorization, we want to create factors that are all prime numbers. So let's review what a prime number is. Let's look at a few numbers. Let's look at 5, 10, and 13. Put 5 in the box. Let's get the factors of 5. 1 times 5, and that's it. There are no other factors. This is a prime number. Let's look at 10. Let's put 10 in the box. We have 1 times 10, 2 times 5. Therefore, 10 is not a prime number. It's a composite number. There are more factors than simply 1 in itself. How about 13? We have 1 times 13, and that's it. 13 is a prime number. So folks, as we go through this process, when we create factors, we got to keep going until we have all prime numbers. Let me show you what that means. Okay. Suppose I asked you to give me the PF, I'm sorry. The PF, which is prime factorization, of the number 20. Normally, if you just gave me the regular factors, you would say they are 1 and 20. It's a bunch of them. 2 and 10. 4 and 5. These are prime numbers. 2, 5. But these aren't. So if I had you list the factors of 20, this would be a correct list. But these are not the prime factors of 20, because look, we have non-prime numbers in here. So let me show you how to do this. I'm going to use the tree method. And actually, I'd like to start with a small number. Let's start with 10. I apologize. So the first thing you do is you break it up into 1 times itself. Then we take this number and we break this down. 2 times 5. Folks, we can now quit because we have prime number, prime number. We don't count 1, we leave that out of the equation. So the prime factorization of this number is 2 times 5. That's it. Let's do another one. Let's look at the prime factorization of 12. One times 12. 2 times 6. Are we done? Answer is no, because 6 is not a prime number. So we got to put 6 in the box and break that down. Now we have all prime numbers. 2 is a prime number. So we have this, this, and this. So here is the prime factorization. 2 times 2 times 3. These are all prime numbers, and when you multiply them out, 2 times 2 is 4, times 3 equals 12. Now, it's also customary to combine these. So you can put 2 to the second power. 2 to the second power means you take this number and you multiply it by itself this many times. So either of these answers would be acceptable here, or the numbers themselves. Let's do another one. This is the type of thing you just have to see a lot of examples, which is true often in math. Let's do the prime factorization of 20. Okay, we have 1 times 20. We have 2 times 10. 2 is a prime number. So we know that's going to be part of our answer. But we're not done, because 10 is not. We got to break that down. Let's put that in the box. 2 times 5 is 10. Are these prime numbers? Let me circle them. Answer is yes. So they go in the answer. We check our work. 2 times 2 is 4, times 5 is 20. And if we want, we can combine these. 2 multiplied by itself twice times 5. Either of these are acceptable. Okay, ladies and gentlemen, I'd like you to try one on your own. Let's do 36. Prime factorization of 36. Okay, I'm not going to do 1 times 36 anymore. Let's do 2 times 18. 2 is a prime number. That's going to be in our answer. Let's circle it. Is 18 a prime number? Answer, no, it's composite. Let's break that down. 2 times 9. 2 is a prime number. It's going to go in our answer. Is 9 a prime number? No. 3 times 3. Are these prime numbers? They are. They go in the answer. Let's check our work. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. That is correct. We could leave it like this, or it would be customary to combine these. We multiply 2 by itself twice and 3 by itself twice. That is, both of these are the prime factorization of 36. Notice, all prime numbers. Okay, let's try one last one. Again, please pause the video and try it. Prime factorization, PF. 2 times 24. 2 is a prime number, it goes in our answer. Is 24 a prime number? Answer no. We can do 2 times 12. 2 is a prime number, goes in our answer. 12, we could keep going. 2 times 6. 2 is a prime number, goes in our answer. Is 6 prime? No. It's 2 times 3. These are prime, 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 prime. That is the prime factorization of 48. Let's check our work. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. Let me prove that to you. 16 times 3 is 48. Folks, we can leave it like that, or we can combine these. We could say 2 multiplied by itself 4 times the number 3. Either of these would be acceptable as the prime factorization of 48. This is how I'd like you to do it, folks. This is a little bit more advanced. 2 to the 4th power. We haven't spoken much about exponents yet. We'll get there shortly.